Welcome aboard Astra, the Exo Marketing Podcast. I'm Jessica Kurz, your guide to the universe of space commerce.
And I am Xylo the droid, ready to process and illuminate the fascinating intersection of space and industry.
Today, we're diving deep into something that, honestly, sounds like pure science fiction, but is actually becoming reality pretty fast. Orbital manufacturing. Forget dusty old factories on Earth for a moment. We're talking about building, advanced materials, life-saving drugs, all in the unique environment of Earth's orbit. Orbital manufacturing, it still has that sci-fi ring to it. What exactly is it? I mean, beyond just, making stuff in space.
At its core, it's about harnessing the specific conditions of microgravity that near weightlessness you get in orbit.
Right.
And using that to create materials and products that are just far superior to what we can manage on Earth. Think of it less like copying an Earth factory and sticking it in orbit, and more like using space itself as a key ingredient in the manufacturing process. The goal isn't just making things in space.
It's making better things.
Exactly, making better things because of space.
So this isn't like assembling satellites or fixing the space station parts. This is creating completely new materials, new products from scratch up there.
Precisely. It's really a new paradigm in industrial capability. It's driven by the basic physics of what happens when you take gravity mostly out of the equation.
Okay.
We're talking about a shift that's potentially as big as, say, the Industrial Revolution.
Yeah.
But microgravity is the main tool this time. The focus is definitely on developing these next-gen products.
Right.
With much higher quality, better performance, and ultimately, they're designed to serve life back here on Earth, to improve things for us.
Space that serves life below.
I like that framing. It connects it back.
Yeah.
So what is it about this lack of gravity? Why does it make such a big difference? What's the science?
Well, what's really transformative is how microgravity messes with, or rather, changes fundamental physical processes, like mixing, for example.
Okay, mixing.
Yeah, on Earth, gravity makes heavier stuff sink, right? That's sedimentation. And temperature differences create currents convection.
Sure, happens all the time.
But in orbit, those forces are tiny, almost gone. So you can blend materials incredibly evenly. Imagine creating an alloy where every atom is perfectly distributed. That's just almost impossible down here with gravity pulling things around. So these are just tiny little tweaks to how things are made. These are fundamental changes in material formation, leading to potentially huge advantages.
Absolutely. It's not about small incremental improvements. The subtle effects of microgravity unlock completely new ways to make things, new possibilities in material science.
Right.
And that translates directly into, well, significant commercial advantages, obviously. But more importantly, entirely new types of products with capabilities we haven't seen before.
Okay, this is fascinating. Let's make it concrete, though. Give us some examples. What kinds of actual products are being made or developed up there right now?
Okay, one of the really compelling ones is ZBLAN optical fiber. It's a special type of glass fiber. It has the potential to massively increase internet speeds and data capacity. And it's also pretty important for things like quantum computing.
But there's a catch making it on Earth.
Big catch. Gravity causes tiny little crystals, imperfections, to form when you make it here. Flaws.
But in space?
In microgravity, you can produce ZBLAN fiber with, get this, up to 100 times fewer of those defects.
100 times? Wow. What does that actually mean for us?
It means data transmission could be exponentially faster. Signal clarity, way better. We're not just talking faster Netflix streams, though that's nice. It's about enabling future tech, things we're only just starting to imagine. Really powerful networks.
That's a staggering improvement factor. Okay, What else? What other areas are seeing this kind of potential?
Pharmaceuticals, that's another huge area. Growing protein crystals in space lets them form larger and in a much more ordered, perfect structure than they typically do on Earth.
And why is a bigger, more perfect crystal better for medicine?
Because it allows researchers to map its atomic structure much more precisely. You get a clearer picture.
Like a better blueprint.
A much better blueprint. And if you understand the structure of a disease-causing protein perfectly, you can design drugs that target it much more effectively, like a key fitting a lock perfectly.
Okay.
So think about treatments for diseases like Parkinson's, Alzheimer's, various cancers. Getting these high-quality crystals from space could be a major breakthrough in developing better drugs.
Hmm.
It's a very direct link to improving human health.
It's kind of mind-blowing to think the fight against those diseases is literally going orbital. What else is happening up there? Any other big innovations?
Bioprinting is another really exciting one. Microgravity is changing how we can approach it.
Bioprinting, like 3D printing tissues.
Exactly. Gravity makes it really hard to print complex 3D biological structures without using some kind of support scaffold to hold things up as they form.
Right, things would just collapse.
Pretty much. But in space, you can actually bioprint tissues without needing those scaffolds.
Scaffold-free bioprinting, what's the big deal there?
Well, it lets you create more intricate, more functional tissues. Things that more closely resemble, actual human organs in their complexity.
Okay.
Companies like Redwire, for instance. They're actively working towards manufacturing actual transplant-grade tissues in orbit. Imagine a future where you could potentially grow replacement organs in space. It could theoretically solve the huge shortage we have down here.
Okay, so faster internet, better medicines, potentially lab-grown organs. Are there other material advances too?
Oh, yes.
Yeah.
We're also seeing really interesting progress with advanced metal alloys and semiconductors.
How so?
Well, for instance, certain combinations, like titanium and aluminum. In microgravity, they can form bonds that are much stronger and more uniform.
Stronger alloys. What would we use those for?
Think lighter, more durable, more heat-resistant materials. That can mean more fuel-efficient airplanes, satellites that last longer, maybe even materials strong enough for future tech, like fusion reactors.
So really diverse applications then.
Immense diversity, yeah. It touches a lot of different high-tech fields.
Okay, it definitely sounds like this has moved way beyond just theory. It's happening. Can you give us a sense of the timeline? What were some key moments getting us here?
Sure. I mean, the idea's been around for decades, but the last 10 years, maybe 12,
Yeah.
that's when things really started to accelerate, turning the idea of orbital manufacturing into, actual practice.
So walk us through some highlights.
Okay, back in 2014, you had Made in Space. They did the first 3D printed object on the ISS. That was huge. Then jump to 2017. That's when the first actual production of that ZBLAN fiber happened in space, showing we could make these high-value materials, not just test prints.
Okay, so moving from can we do it to can we make something useful?
Precisely. Then 2021, you had Redwire and NASA working on bioprinting, those tissue scaffolds we talked about, pushing the biotech angle. Then a really big one was 2023, Varda Space. They launched an autonomous capsule and manufactured stuff in orbit all by itself, and then returned the capsule to Earth, proving that commercial drop return model could actually work.
Yeah.
And now this year, 2024, commercial in-space production.
Yeah.
It's really solidified as its own distinct investment area. People are putting serious money into it. The European Space Agency, ESA, is very active as well. They sponsor a lot of in-orbit manufacturing tests, like their Bioreactor Express service, and they're coordinating efforts across different European countries, France, Germany, others looking at sustained production possibilities.
Any other major players?
China, definitely. Their Tiangong space station has dedicated facilities for material science, tissue engineering, semiconductor research, all in microgravity.
Right.
Now, their programs might be a bit less public, maybe more state-directed, but they are, without a doubt, a major player pushing these technologies forward. It's clear that nations worldwide recognize the strategic and economic importance here.
Okay, this is all incredibly cool, but let's talk business. How does this actually work commercially? How do companies actually do manufacturing in space? What are the models?
Yeah, good question. We're seeing several interesting business models pop up. One common one is sort of an orbital factory as a service. Basically, companies can rent time and resources.
On the ISS or other stations?
Exactly. On the ISS now or on the private space stations that are planned for the future, you book lab time, basically, to do your own R&D or production runs in microgravity.
So renting orbital lab space. Got it. What else?
Then there's the model Varda Space is pioneering those autonomous drop return capsules.
Right, the ones that make stuff and come back.
Yeah, they operate independently, make their specialized product, probably high-value, low-volume stuff, and then bring it back down. That's a neat self-contained approach. Looking ahead, you might even see things like space station licensing.
Licensing, like renting out a whole module.
Or maybe even companies getting naming rights on orbital factories, really commercializing the environment up there.
Interesting.
And finally, you're seeing these hybrid ventures where, say, a big pharma company or a biotech firm partners directly with this space tech company.
Her mining expertise.
Exactly. Pooling their knowledge, the drug development know-how with space operations know-how to create and make new products in orbit together.
Okay, so it's a pretty dynamic landscape, lots of different ways companies are getting involved. What's the sort of the big economic picture here? What's the market potential they're seeing?
The projections are, well, they're pretty significant. Current estimates suggest the market just for orbital manufacturing could top $10 billion by 2030.
10 billion, just in the next, what, 5 or 6 years?
That's the projection. And looking further out, say to 2040, some analysts think the broader in-space manufacturing sector, which might include stuff on the moon or asteroids, eventually could hit $100 billion.
Wow, okay, those are serious numbers. Is there real money flowing in to back that up, or is it just hype?
No, there's definitely real investment. Just look at NASA and ES. Over the last 5 years, they've put in over $500 million combined just into microgravity manufacturing R&D.
$500 million from the big agencies alone.
Yeah, that's a pretty strong signal, isn't it?
Yeah.
It shows they really believe in the long-term potential and, frankly, the game-changing nature of this field.
So definitely not just a flash in the pan. This could be a major economic force.
It really could be. And that brings us to a really interesting question, especially for you listening, maybe if you're in marketing or just curious. How do you actually market this stuff?
Yeah. How do you sell products made in space? How do you take something so advanced, so out there, and make it connect with people or businesses back on Earth?
Well, the key seems to be shifting the focus, moving away from just the wow space factor or the complex science, and really zeroing in on the tangible benefits for the end user. It's what some people call outcome-centric storytelling.
So less about how it's made, more about what it does for you.
Exactly. Instead of explaining microgravity physics, you highlight the results. This medicine works better, this internet connection is faster and clearer, this material lasts longer or is more efficient.
This drug, perfected 400 kilometers above Earth, targets cancer cells like never before.
Precisely. That immediately connects the space element to a clear, powerful, personal benefit. It grabs attention.
Okay, that makes sense. What else are companies doing?
We're also seeing this rise of lab-in-the-sky content, turning the actual experiments, the manufacturing process is happening on the ISS or other platforms, into engaging stuff.
Like documentaries or videos?
Yeah, videos, documentaries, maybe even VR experiences.
Yeah.
Giving people a window into this incredible orbital production line. It helps demystify it and build excitement.
That sounds cool, building public awareness.
Right. And I think we'll see more cross-sector partnerships, too. Storytelling collabs between the space manufacturers and, say, the companies providing lab equipment, or even logistics companies involved in getting things up and down.
Showing the whole ecosystem working together.
Exactly. Illustrating that whole journey from Earth to orbit and back again, making it feel more real and accessible. I think the fundamental principle, the core idea is this. If you can connect the extraordinary world of space to the ordinary, everyday lives of people on Earth, then you win. That's the key.
Connecting the stars to everyday life.
You got it. The power of orbital manufacturing is that it's both like totally futuristic and mysterious, but also potentially incredibly useful and practical. The communication job is bridging that gap.
Okay, practically speaking, how do you build that bridge? How do you make these advanced concepts relatable?
Well, analogies help. Clear, relatable comparisons. Instead of just talking about, reduced convection currents.
Right.
You might say something like, imagine mixing cake batter perfectly with no heavy bit sinking. Space lets us do that with metals, creating flawless materials. It gives people a hook. Visual storytelling is also huge, showing the process. Maps, animations, videos, illustrating that journey from launch to production in orbit to re-entry and delivery, making it tangible.
Let people see it happen.
Exactly. And maybe most importantly, tap into the hope, the positive human impact. Highlight the potential for healing people, for creating a more sustainable future with better materials, for connecting the world faster. Focus on the why that matters to everyone.
So it really comes down to telling a powerful story. The story of how space, this extreme environment, is actually becoming a service.
Yes.
A service delivering real benefits back down here to Earth.
Precisely. And that's a story that, honestly, we're only just starting to tell. It's unfolding right now.
This has been absolutely fascinating, a really great deep dive into orbital manufacturing. Thanks so much for shedding light on this.
My pleasure. It's truly a transformative field to watch.
And if you enjoyed this exploration into the factories literally orbiting our planet, definitely make sure to like and subscribe to Astra, the Exo Marketing Podcast. We'll have more deep dives into the amazing intersection of space and commerce.
Stay tuned.
Yes, stay tuned for our next episode. And always remember, reach for the stars, deliver to Earth.